These stepped red brick ruins towering over the landscape of Bihar, India, are the surviving footprint of the ancient world's greatest intellectual center, Nalanda University. To understand how this multi-story campus was built, we have to sink these ruins back into the earth and return to the untouched 5th century plain. There is no steel, no heavy machinery, and no modern cranes. The engineers of the Gupta Empire had a strictly limited toolkit. They relied entirely on baked mud, thick timber, elephants, and sheer human labor. To see exactly how they solved the logistical and structural problems of a megacampus, we are going to rebuild this architectural marvel from the ground up, step by step. Step 1 is clearing the dense vegetation of the Bihar plains. This requires a coordinated effort between hundreds of working elephants and thousands of manual laborers, pulling up brush and leveling the soil. Next, workers carve perfectly straight geometric foundation trenches deep into the earth. Every cubic foot of dirt is removed entirely by hand. Looking at this isometric blueprint, we see a strict architectural grid. It divides the campus into 2 distinct zones, a continuous row of square viharas, or monasteries, directly facing a row of chaityas, which are sacred temples. On the far left of the grid, an oversized isolated square foundation anchors the site, designated for the main spiritual monument. Stretching down the right side is a highly repetitive cellular grid. These interconnected foundations are designed to house thousands of scholars. With the trenches dug, workers lay down millions of custom-baked red bricks. This paving process locks the sprawling grid firmly into the earth. This rigid mathematical foundation reveals that Nalanda was a meticulously master-planned city, designed for ultimate scale. To safely build residential buildings up to 4 stories high without a steel framework, engineers must construct brick walls with incredible thickness at the base. Feeding this construction requires a relentless logistical supply chain. Fleets of heavy-duty wooden and bamboo ox carts constantly deliver mountains of heavy red bricks to the active work zones. As the walls rise, laborers assemble a dense web of bamboo scaffolding. Tying the stalks tightly together with ropes creates a highly organized framework that allows artisans to build higher. Inside those rising walls, the internal layout takes shape. Thick, compartmentalized walls form wide verandas and individual monk cells that border vast central open courtyards. By mastering this continuous supply chain of mud and bamboo, ancient engineers successfully achieved a massive vertical scale for human habitation. We now shift our focus back to the far left of the grid to build the Sariputta Stupa, the primary spiritual and visual anchor of the entire campus. The structural strategy here is to build the stupa in stepped pyramidal terraces. This broad base distributes the immense weight, allowing them to achieve massive height without the walls collapsing inward. Adding heavy elements requires brute force mechanics. Workers use thick ropes, wooden pulleys, and massive earthen ramps to haul colossal stone blocks up the rising tiers. Along the corner towers, artisans delicately install intricately carved stucco Buddha figures into specifically engineered decorative brick niches. The construction of the Great Stupa perfectly fuses heavy load-bearing structural engineering with delicate artistic devotion, creating an immovable anchor for the university. The final structural challenge is perilous. Workers must cap off the completed 4-story brick towers entirely without the use of modern cranes. They precariously hoist massive, heavy timber beams to span the tops of the walls. These timbers create the flat roofs and establish the upper-level floors used for the campus libraries. With the roofs in place, artisans apply the final finishing touches. They carve intricate geometric patterns and shape arched doorways directly into the settled brick. Capping the open walls with these thick timber roofs transforms a maze of raw brick into functional, protected hubs capable of storing the ancient world's greatest manuscripts. Now, we rapidly dismantle and clear away the massive bamboo scaffolding networks across the entire campus. Stripping away the timber reveals the raw visual impact of the architecture. The pristine, newly baked red brick glows beautifully under the open Bihar sun. Next comes the vital introduction of living landscaping. workers plant lush Bodhi trees and fill geometric brick ponds with water and lotus flowers. Finally, there is a sudden, vibrant influx of life. Thousands of international scholars and monks enter the gates and fill the wide brick pathways. Through sheer human ingenuity, utilizing nothing but mud, wood, and collective labor, these ancient engineers successfully built a living, breathing architectural marvel that rightfully became the intellectual center of the ancient world.